According to NASA, seeing the total eclipse of the moon and the rising sun simultaneously is called a selenelian, a phenomenon that celestial geometry says cannot happen. How then does NASA explain it? Well, thanks to Earth's atmosphere, the images of both the sun and the moon are apparently lifted above the horizon by atmospheric refraction. This illustration was done by a Gl0be proponent, and as you can see, his Terminator guy is seeing the sun and moon in their apparent positions. But at the same time, another observer far west of Terminator guy is able to see the moon much closer to its actual position up in his sky. So let me switch this from lunar eclipse to solar eclipse. His Terminator guy is still seeing the sun and moon in their refracted positions on his horizon just like before. Only this time the refracted moon is eclipsing the refracted sun. And at the same moment in time, another guy far east of Terminator guy is able to see the sun and moon much closer to their actual positions up in his sky. Only this time he's seeing the moon in its actual position eclipsing the sun in its actual position. And that's my irrefutable argument in a nutshell. Without refraction lifting the sun and moon higher than their actual positions, selenelian eclipses are 100% impossible in the heliocentric model. But with refraction lifting the sun and moon higher than their actual positions, solar eclipses could be viewed from multiple locations on Earth at the same time. So, is the observer of this Australian solar eclipse sunrise seeing the sun and moon in their actual positions or their refracted positions? Gl0be answered, both sun and moon in their refracted positions, obviously. Okay then, let's draw it that way. And as you can see in the image below, the refracted moon is clearly eclipsing the refracted sun. And where is the true position of the sun and moon? Gl0be says, below his horizon. Yep, that's what your model says, so let's draw that in. And wouldn't that allow a person beyond his horizon to also see the eclipsed sun at the same time? Gl0be says, Australian Terminator guy is seeing the eclipse, while Pacific guy is seeing the sun and moon separate. Wait, what? I think Gl0be has forgotten how solar eclipses work in the heliocentric model. If the true position of the moon is between the sun and the Earth, then that moon is casting its pointy little shadow on the Earth, and a person within that shadow is seeing a solar eclipse. Let me show it using Sly-Sparkane's scale model. This is what our Australian Terminator guy captured on film, an eclipsed sunrise. So there's no question that he witnessed an eclipsed sun rising, right? There's no question that he saw an eclipsed sun at the precise moment in time captured in the still shot above, right? And at the very beginning of his footage, this is what he saw. The very upper limb of the sun and moon just starting to peek over his horizon, as shown in this image he captured of the event, right? Now what Gl0be, NASA, and the entire heliocentric model is saying is that when our Australian friend saw this moon peeking its head up over his horizon, he was actually seeing the moon in its refracted position, half a degree, or 1 full moon diameter, higher than the moon's true position at the precise moment in time captured in this still shot. And what Gl0be, NASA, and the entire heliocentric model are also saying is that the true position of the moon at the precise moment in time captured in the still shot above was a half a degree, or 1 full moon diameter, below our Australian friend's horizon. They're saying that the moon's actual position was here, casting its pointy shadow on the Earth, while our Australian friend was seeing the moon in its refracted position eclipsing the sun. And because Gl0be has apparently found himself in a very awkward position, he's claiming that this other guy, standing in the middle of the pointy moon shadow, is seeing the sun and moon separate. Is that really how solar eclipses work in your model, Gl0be? A person can be in the moon's umbra, but unable to see an eclipsed sun? While we give Gl0be some time to sort this out, I'll be working on a video that further debunks the unsubstantiated refraction lift claim, using this same Australian sunrise, but a different attack. And I've already begun a video that will show how my single-axis astro tracker also debunks refraction lift. Thanks for watching, guys.